Now we'll talk about the motion of a body up the rough inclined plane. Earlier we have seen down. Now in this case up. That means the body is moving up. Now, first of all, now the body which is at this now here, it has to move upward direction. That means we need to push with certain force. Some force has to be added. Right, so we assume that some force is applied, and let us assume that this block is moving upward direction with certain velocity, initial velocity u. We have thrown the body moving some velocity u upward directions. Now, when the body reaches to at this location some point, let us consider. Now we need to analyze the motion of a body now. Tell me now here, what is the first thing we need to resolve into components? Tell me the components now here. This is a normal. And these are the components. Right, so this is n. And this direction, what we have, tell me now? mg cos theta. And this direction we have mg sin theta. Now, which direction the block is moving? Upward direction. So then which direction of friction will act? Downward direction. So this is the frictional force now, tell me. But the block is moving which direction? Upward direction with some acceleration A. Initially block is moving upward direction with some initial velocity u. Now, so you tell me now, let's find the acceleration of a body. Tell me now. Acceleration equal to net force by total mass. And do we have any force acting on the body along the acceleration? Yes, there is no force. So here this mg sin theta opposite to body motion. Frictional force is opposite, but the body moving because of the initial velocity. Because of initial velocity, it's moving upward directions. Right. So what is the acceleration of a body? Tell me now. So that means 0 minus, what, tell me now? mg sin theta. Yeah, so that is, we can say plus f na, minus we have taken common by f. Okay, where what is this f is friction. How much the frictional force now here? That is mu into n. So how much the n value? Yes, so that is mu mg into cos theta. We'll place now here. So that is A is equal to, that is minus mg sin theta plus what, tell me now? Mu mg cos theta. Mu mg cos theta by m. Okay. So then what will be the acceleration of a body now here? This is m, take mg common. So that is g into what I'll get, you tell me now. This is sin theta plus mu cos theta. This is the acceleration of a body. If a body moving up the plane, that minus sign is opposite direction. And we'll find, so from here to here, let us assume that the body reaches from B to A. When the body reaches to the point A, let us assume that the final velocity of a body 0. Final velocity of a body 0. Now let us find out this thing here. How much the time the body will take to reach the point A, and how much the displacement it will cover. That we need to find out. So in this case, what we do here, tell me now here. So when the body reaches to the highest point, final velocity of a body 0. So tell me now here, initial velocity we have something we have, and initial velocity we have a u, and final velocity, how much you tell me now when the body reaches to highest point 0. And acceleration, how much you tell me now, this is minus g into what, tell me now, sine theta plus mu cos theta. Sine theta plus mu cos theta. And then, so displacement, which I am calling it as something, yes, we are calling. So which equation I use now here? Final velocity we know now. We can apply the v squared minus u squared, which is equal to 2as. So final velocity 0. 0 minus initial velocity, that is u squared, which is equal to 2 into, this is minus g into what, tell me now, sine theta plus mu cos theta into s. So minus will get cancelled. So will come the s is equal to what, tell me now, that is u square by 2g into sine theta plus mu cos theta. Yeah, displacement of a body. Displacement of a body before coming to rest. Now let's find the time also. So you tell me now time. So time case we use the formula v is equal to u plus at. Final velocity 0. Initial velocity we have, this is minus a is equal to g into sine theta plus mu cos theta into t. Now simplify, get the value of t. T will come to be what, tell me now? Mu by g into what, tell me now? Sine theta plus mu cos theta. Right. These are the things for the, if the body moving, which direction you tell me now here? So up the plane. Right. Now you see this thing here, if the body is moving up the plane. So in those cases, the things what you need to remember. So body moving up the plane. Up the rough inclined plane. Rough inclined plane. In those cases, the things you need to remember here is acceleration. So A up if I call. What is the acceleration formula you tell me now? That is minus g into what, tell me? Sine theta plus mu cos theta. So here we have this minus sign indicate the opposite direction. Sometimes we note confuse minus sign. Right. And you can see now here the displacement equation, displacement before coming to rest, which is equal to u square by, we can say now, 2a, where a we can place here. That's what I'm saying here. So that don't consider sign. Sign indicate the opposite directions. Right. Next we have, in this case, time. Time t is equal to what? Tell me now here. So that is u by g. That's what we have seen now here. By distance. Yeah, a here, not g, a. A means a up here.